All right. Let's continue. So the next step is that we want to be able, our server should be listening to multiple different URLs, not just a single one. And the way you do that is you just add another route decorator with another function. So for instance, if I want my server to also listen to, in this case, it would be the server address .user, maybe I want to list all the users in my system, then I add a app.route/user here, and that function, the function underneath will now be called whenever I'm visiting this address here. And so my function now is a bit more HTML-like, so I have a bunch of users in a dictionary, and I join them using the join function and present them also with a nice header. So now if I run this program, or this server version, and I visit my user address, so if I go to /user here, then it doesn't do anything. Oh, there we go. So then we get our users presented. So this is the header and then the two users that we had. Then sometimes it's useful to have URL addresses that match for any name. So essentially parameterized URL names. So for instance, if I want to accept any /user/ arbitrary name, I can use a placeholder with these sharp brackets. And the name of the placeholder will then be passed as a parameter to the function underneath. So for instance, if I want to accept anything /user/username and I want to show that user's profile, then the name of the function here, by the way, is arbitrary. So it doesn't really matter. I just choose something relevant. And so then you can, for instance, just in this case, just user and then show the username. But of course, now you could make a query to a database and find all the user information about that user and present it in a nice way. So this now, if I run this server, I can go to, essentially now I can go to user. So up there, if that's too small, I'm typing in /user/ let's say, Simon, and then the server answers with user Simon, and of course the content is here empty, but it could be more complicated. So far, we haven't really returned HTML code. We've just returned simple text, but in order to do things correctly, we should return HTML code. So of course, what we could do is we, in our functions for every route, we could now return full HTML code. And so that would be kind of a long text string that we would need to generate every time and return it. Now that works well for simple text like this, but if you think back to the Aftenposten page where we had pages of HTML code, this becomes very cumbersome very quickly, and your source code will be completely filled up with HTML code. So for that reason, Flask has something called templates. And templates are essentially just files that you have as part of your project, HTML files that are parameterized. So they're HTML files with placeholders in them, and you can plug in variable values. You can replace these placeholders with variable values. And so then what you do is you render that. So for instance, here I have this post.html. This is my HTML page that is parameterized. And it's parameterized through it has this name variable that is not filled out yet. And then I can call this function render template, provide the file name, and provide the values of the variables that I want to have filled in. And this render template function essentially replaces the placeholders with the specific value that I contribute. that I provide here. And then I can return that instead. So now the HTML code, I removed it from the actual source code of my Python script, but instead I now have it in an external file that I load in and change maybe some parameters values if necessary. This is how this file posted.html looks like. So it's important that this lives in a subdirectory called /templates. So in templates are all these template files. And so you can see here I have, this is essentially standard HTML file, but I have this parameter name here that is the placeholder. So it's curly bracket, double curly bracket, name, closed curly bracket. So whenever you have a double curly bracket, so this is its own language, right? So this is an extension of the HTML language specifically for Flask templates. So essentially you have these double curly brackets whenever you want to have a placeholder that should end up in the HTML file. There's also, you can have if statements in your templates. So if you want to show certain texts only in specific cases, you can use the curly bracket percentage sign with some conditions. And then here's an else case, and then there's an end if case. So essentially now, this template here shows if a name is provided, if a valid name value is provided, then it shows displaying blog post for that name. And otherwise, it just shows no post name given. Okay? So it's a template that kind of handles blog posts for valid names and not. And you can see that in my routing up here, I actually have two decorators here. So I allow this function now will be called whenever I visit /post/, and so I don't provide a name here, or if I call /post/placeholder name. And you can see my function underneath now has name equals, and there's actually default parameter. So in case where I visit just /post/, the name will be none. And if I'm in the second routing case here, I will have the name that was provided as part of the URL. And so depending on that, in that case here, I also end up with the two different cases in the template. Does that make sense? So you can, of course, test this now. So let's just define this and we run it. So now if I visit this URL localhost 5000 /post/history of signs. Right? So that's a valid name, and we should see displaying blog post of history of signs. So that worked fine. And then if I remove the name, then it says no post name given. Okay. So the reason why this templating is quite important is because you want to separate the logic, the Python logic, from the actual way how it's displayed, right? These HTML files that can be quite lengthy, they should live somewhere else so that you can focus on the actual logic in the program. So far, we've only been displaying, we made GET requests from the client, but we've never actually sent data from the web browser to the server. And that's a very common task, right? The server should fill out some forms and then send them to the web server and then receive the answer. So we need to learn how we can send information from the web browser to the server. And that's done through something called HTML forms that I haven't showed you in the introduction of HTML yet. So an HTML form has exactly the purpose of sending data from the web browser to the server. The way you do that, you create a form is with this form tag in your HTML document, and then you have some form elements, and then you close the form tag again. So here are the most common forms that you essentially find all over the web. And so you have text inputs. You can type text in here. Then you have a checkbox. So for checkboxes, you can only you can click one, or you can click two, or you can click none. Then you have radio buttons. And then you have a button where you can submit your, all this data to the server. And so now if I look at the underlying HTML text, this is what it looks like. So I have my form, tag name, and then I have for every I have these input tags here. So you have an input of type text, and I always give every input a unique name so they can identify later on, so that the server can identify. I will use the identifier first name later on to get the content of that input. Then here's the checkboxes. So for checkbox, I use input type equals checkbox. And then again, I use the same, again, give this a name so they can reference it later on. Radio buttons are just input type equals radio. It's just the same. And then the click button was an input type equals submit. And that's it. So essentially, this HTML code now allows us, at least from the user perspective, from the browser perspective, allows the user to input data. So just a comment on this input element, the text input element, so type text. So normally when you type in values here, you see this immediately, right? But you can also change it. So if you have, sometimes it's useful to have, for instance, passwords. And then what you can do is, so here I have first name, last name, and password, and I use an input type text, and then input type password. And so here, right, if I type in my name and then my password in the last one, you just don't see the text. But of course, still, as soon as I click submit here, both the first name, last name, and the password will be sent as text over to the server so that the server can compare the password with what it has stored in the database. And the last important thing is the submit buttons. So here, whenever you have a submit button, the form needs to know to which URL it needs to send the data to. And that URL is provided here in this form action parameter. So here you specify to which server endpoint the data is being sent to. And so in fact here I also specified a method. So normally forms are being sent over as a post method, but here I made an exception because I wanted to show you that I can create an input that when I type in some text here and click submit, then we will actually go to the Bing web page and make a search request. So you can see here as an action I used bing.com/search, and then I have a specific input text that has the parameter Q. And so that's just because I know that the Bing website evaluates the what you pass in as a Q parameter, and it performs a search on that. So I don't know, I can search for violin here and click submit. And then I end up on bing.com with the search term inserted up here and the search results down here. And so we made a request, using our form, we made a request to the Bing website to make a search for violin. And that's exactly now what we want to do also from the server side, from the Python server side. So for instance, let's say we wanted to extend our server so that it takes in, that we have a login page. And the first thing that I do is that I create a new template, templates/login.html, and that template contains the form that I'm looking for. So it has a title, and then I also, you can see I have kind of an error handling here. So if I call the render template with an error variable, then there will be some red text appearing on the website. So that's often quite useful to have in any template. But then here's the main part, right? So here's my form, and essentially I have one input with the username, one input for the password, and one submit button. And so when I click on the submit button, then I want to make a post request because I'm sending data to the server. So for that, we typically use post. And it should be sent to the endpoint handle login. So we need to implement in a second that the server handles that. So that's our template. And now we can just create a route that renders the template. So I create a new route /login, and I say render template. And I said no error messages at this point. So we can run this, and we can go to login, and we see our nice login screen. So now the question is, how do we, of course, that will break now, but if I press submit here, then the server doesn't really know what to do with the data because we haven't implemented the post endpoint yet. So the form above sends a post request to this login handle login. And so we need to do that. And so the way we do that is we create a new route that listens to /handle login. And now we also provide a methods parameter because we want Flask by default only listens to GET requests. But we want this URL endpoint to listen to a POST request. Okay, so we add this methods equals POST here. And once now in the function underneath, we can use this parameter Flask.request to get any form information that the user has passed through that POST request. So I think it's best to see that in full code. So here's my route app where I have handle login and then the post method. And here's the function, the actual function. So first what I do is I check that I'm actually performing a post request. I mean, this isn't really required. I just wanted to make sure that. So I can ask request.method, and it should be post. But here comes the exciting part. So now I can do request.form username to get the username that has been passed, that had been typed into the form. And I can use request.form password to get the password that has been typed in. Okay? And so these names, username and password, are exactly the ones when I define the input, here I said name equals username, and input name equals password. Right? These are now the reference points that I use in the post request to get the data again out of these forms. And so of course, once you have that, then you can do some checking. Right? So here, if username is Simon and password is safe, then you're logged in. And otherwise I create an error message, invalid credentials, and I render the template, the login template again with the error message. Okay, so now you know my password. Okay, I try to log in, Simon and my secret password. And yes, I'm logged in. Okay, so that worked fine. But now, let's say I use an invalid password. And indeed, we get our nice red error message in here, and it asks me to try to log in again. Okay. Of course, you shouldn't store the password as part of your code. And especially, you shouldn't upload the code then on GitHub. So that actually happens quite often. That people upload their server credentials or whatever as part of the source code. So on GitHub, so avoid that. Okay, I think that was essentially these are the core components that you need for web programming. Right? So now we can present HTML. We can present HTML documents to the user that are parameterized through our Python program, and we can ask the user to input some data. And we can get that data again on the Python program, operate on it, and then present the results again in the form of an HTML document. Any questions so far? No. So then what I was planning to do for the rest of this lecture is to implement this game. And so we'll start very simple, and we kind of make it more and more complex as we go along. Okay, so I have multiple versions of the game, and we start, as I said, we start very simple, and we make it more and more complex. Oh yeah, we keep these statistics here. So the very first version of my game is shown here. So I have a Flask server, I create a new app, and I just create a simple route that listens on the main, just on the slash URL. And so what I do is I just return some header and a link that launches the game. So here is this is our first main project that we need to implement, so /select. And then I just run it. And I run it with the debug equals true because we might want to do some changes. So now we can test this. So I go to, so when you run the server, it tells you down here where it's listening to. So it's in 127.001:5000. So I can, so let's go to that URL, 127.5000. Let's go large. There we go. Welcome to the Magic Door game, and we can launch the game. But of course, if I try to do that, the server complains that we haven't implemented the /select endpoint. So we need to do that. So here's my second version. Oops. Okay, it looks, this is now the new server code. So the first part is exactly the same. I've only implemented these 3 lines down here. So I now have a new route /select. I just call the function here new, but again, as I said, the name doesn't really matter. And I render a template here, because the user now needs to select the door, right? So that's the task. So the template is called select2.html. And so in my directory, I have a folder templates, and in that folder I have this file select2.html, and this is what it looks like. So we have a title, and then we have a big form that essentially asks the user to select one of the doors. So you can see I have 1, 2, 3 input files here, and all of type radio buttons with the name door, and the values of these radio buttons are 1, 2, and 3, depending on which door has been chosen. And then the last input is a submit button. And that submit button will send its result, so which door has been clicked on, as a post request to the URL reselect, which we will have to then implement as a next task. But now we can start our game again. So this still works. Now if I click launch game, I end up on this select URL, and we see the nice form that we've created. So now I can choose one of the 3 doors. 1, 2, 3. I can click submit. And now you can see there has been now we are at reselect. And actually down here you can also see that the server received a post request on reselect, but it didn't know what to do with it. So then it breaks again. So then the next task is to implement reselect. So here's the next version of our code. Essentially everything is the same as before. The only new part is down here, this reselect function. And so we create a new route that listens on reselect. Now we have we know that this is a post request, so I say methods equals post. And then here's the actual underlying function. So what I do is I use this request.form. So if you look up here, I now imported from Flask import request. so that I can get the form data. So I do request.form, and I know that the name of my checkpoint, these radio buttons, I use the name door. So I can extract the store information out of here. The form data is always strings, but I know that the only values that I provided was 1, 2, and 3, so I can convert it into an integer. So now the selected variable is either 1, 2, and 3, depending on what the user has chosen. And then I can render the next page. So the next page, the task is to ask the user to either stick to their door or to change their door. Right? So that's what we need to implement next. But for now, the reselect is very simple. So I think it's just parameterized through the door. So I only say you have selected door number, that number, to get started. So now we can play the game again. So I start here, launch the game. I choose a door, and then I press submit button, the submit button. Okay, so now I've made a post request to the server. It executed the, it extracted the door number, right, and it rendered the reselect method here and presented it to us. So now we just have, you have selected door number 2. Okay, up to the next version. So now is where things become a bit more complicated, because now we need to decide if which door should be, we need to give the user, the player, the option to either stick to the door or to change the door. Well, first of all, we need to open one of the doors, right? But we can't open all the doors. We can't open the door where the car's behind, so we can't just pick a random door. So in a way, we now need to change our program to, when we start a new game, we need to decide behind which door is the car actually stored. Behind which door is the car. So the way I've implemented that is our program now has this global variable game states. And whenever we create, that's a dictionary. And whenever we create a new game, so here in this new function, when we select the first door, I create a unique game ID. So here I use the function called UUID that it does that. It just creates a long, unique number, convert that into string. And then I also choose a winning door at that point. So I choose a random integer between 1 and 3 and store that in this winning variables. And then I update this dictionary up here. I say game states for that game ID equals that door. Okay, so now, whenever we start a new game, we know which door will win. So now I have the render template function, but now in the select method, I also need to pass on the game ID. So the game ID is now something that we need to kind of propagate from each page to the next, because we always need to refer back to the game, so that we can check which door has won. So now if you look at the select4.html template, it's still kind of these three radio buttons plus the submit button. The only thing that I changed now is that in the URL, I call now reselect, and I use a different way of passing parameters to the server. So one was these input buttons, and in principle, I could have another input text where I type in the game ID, but here I decided to use a so-called URL parameter. So I pass in the game ID as part of the URL. And the way you do that is kind of use this question mark, and then the parameter and the value of the parameter. Right? And I use the templating formatting of that. So now, when reselect is being called, so now if we go to the reselect method, there was a post method, right? And so I can still use request.formDoor to get the selected door of that the user has selected. But I can also now use request.args.get game ID to get the game ID that was passed to the URL. So now I have both the door and I have the game ID. And now from these two informations, I can extract again so once I know the game ID, I can use our global dictionary to query what is the actual winning door. Okay, so now I have everything that I need again. So I have the selected door and I have the winning door. And so now essentially I need to figure out which door can I open. So I can't open the winning door, that would be stupid, and I also can't open the selected door. I only always want to open the door that is not winning and that has not been selected. And the way I do that is I say, this is just the way this is implemented. So I have the set 1, 2, 3, then I throw away the winning door from that set, I throw away the selected door from that set, and then from the remaining components, I just make a random choice. This is the one that I open. And then I render my reselect function now is parameterized to the game ID, the selected door, and the door that has been opened. And this is what this reselect code looks like. You can tell that this becomes a bit longer. But essentially, I'm just presenting these different results. So I say, you have selected door number. I opened this door. And of course, there's nothing behind it, right? So I've chosen it so that there's nothing behind it. And then I created a new form that allows the user to either stick to the door or to change the door. And now instead of kind of hard coding it, the 3 input files I now created a loop using the templating format. And there's some if statements here. And these if statements are basically checking if the ith door was selected, then I check that I make this the default checked door, because this is kind of what has been previously selected. But also for the open door, I have an if statement, and the open door I disabled. So the user can't actually click on that door anymore because it already has been opened. And then of course I have my submit button, and the results will be sent to /final game ID. So I also have to pass the game ID, of course. So you can try that. So I launch the game, I choose a door. So you have selected door number 1. I open door number 2. I open door number 1. Of course, there's nothing behind. And so now I have my select box, and I can't click the first one because that's the one that has been opened. Door number 1 is the one that I chosen before. So now I can choose between these two. And I click on Let's Go, and that's still missing. So then the last part that we need to implement is this final method. And now, well, that's easy. So I'm listening to final. It's again a post request because I've clicked the submit button. So essentially what I do is I extract again the selected door, the final selected door. I get the game ID. I get the winning door using the game ID. And I check if selected equals winning. And if that's true, then has1 is being set to true, and otherwise it's set to false. And then I render the final page. And of course, with the parameters through has1 and also through the winning door, so that I can tell the user which door he should have chosen. Right, so this is what it looks like. So you have an if statement, if has1, then I show the congratulations message, and otherwise I tell the user which door would have won. And then at the end I have a link to play again. So that's it, that's the full game. So you can now try it out. So I choose one door, and okay, I've won. So then I can play again. But of course, so that's a bit boring still. It becomes, because what we wanted to know is which strategy is the best. So then what I've done is I implemented I created a strategy, or is it called statistics route. Okay, so this statistics route now collects all the information about all the games that have been played and presents them in a nice format. And this is not so, essentially the only thing that I needed to do here is to remember, this global dictionary game states. Before it only stored the winning door, but also now I extended it a little bit so that it stores also the doors that have been selected, the doors if the user changed his or her mind or not, and so forth. So I just kind of collect more information about the game, and the statistics page just presents it in a nice way. Yeah. So then the final version that I wanted to show you is to make it prettier. So far, everything has been kind of, it's not a very nice user interface that we created. And so there are a few tricks that you can use. What I've done is I created so-called layout template files. I used something called Bootstrap, which is a library that makes a lot of these forms look nicer and so on. And I also added images for the doors, for the winning and losing doors. So I want to show you, for instance, how this is being done. So now when you choose, this is the template for choosing a door. And you can still see I have these input files, but now I also kind of have an image that just shows the doors, right? So this is how you would do it. So now if you look at this, you can see it looks a lot nicer than before. Once you have the logic there, right, then it's really just a matter of adding some more style things and to make it look beautiful. You can choose a door here. I click, OK. I got a, right, and then I can stick to that, for instance, and then, right, I've lost. OK, but the exciting thing now is that this last surfer actually runs publicly. So you can now officially access my computer. So if you have a mobile phone and you're connected to UdoRome, you should be able to go to this. Let's see. In principle, if you visit this web page, okay, then you should be able to play the game. And if you don't mind playing a few times, then we can create some statistics about. I can open up the statistics page. Okay. I hope this works. It doesn't work? Are you connected to your UdoRome? Okay. I'll try to. Oh yeah. Yeah, so we can, but is it not? Oh yeah, no, but there's no requests coming in. So is no, can anyone access?
I got in, but launch game doesn't work. Or it's loading.
Is it loading?
It's fine.
Okay. Okay, maybe let me restart the server then. Okay, try again. Yeah, at least I got some.
Yeah, got in now.
Yeah, so this depends on the network. So depends if we have to be on the same network in order for you to be able to access it. But are there some who are able to play?
Might be need to connect it to the
Some.
same rack.
Yeah, exactly. Yeah. So I don't know. Okay, but the statistics page hangs. That's a good sign. There we go. Okay. So what it shows us, it shows us if you changed your mind, you won out of 5 out of 9 cases, so that's 55%. And if you don't change your mind, if you won, then you have a 41 success rate so far. Okay. So now we're at 63% success rate for changing and 46% for not changing. Okay, if you play for another minute, then we have maybe enough data. I'll also play once more. Yeah, I mean, this looks quite good. So now, if you look at the statistics, there seems to be a significant difference, right? We've seen this in our initial results, but also now we have 16 and 20 data points for both strategies. And so if you change your mind, it seems like you have a higher percentage, higher success rate than if you stick to the original door. And in fact, if you think carefully about this, or if you look it up, you'll find out that changing your mind actually increases your chances from, so initially, right, you have 3 doors, so your chance is going to be 33%. And that chance also doesn't change if you never change your mind. If you just stick to that door and you don't care about which other doors being opened and so forth, then you'll have a 33% success rate. So this strategy not changed and won should be 33%. And if you perform enough experiments, it should hopefully converge to that. But the surprising thing is, if you change your mind, then you actually get a 67% or 66.666 success rate of winning. So that's kind of the story behind that Monty Hall game. And our data also suggests that. So you can think a little bit about why that is until next week. Any questions? No? Okay, see you next week.